Today we are going to graph radical functions and determine the domain and range of a radical function. So the basic shape of a graph containing a radical function is a half of a sideways parabola. So if you know our parabolas, they normally look like this. If I go sideways, it would look like that. And half of it would be like that. So basically this is the shape of a radical. Now it could also be this way, or it could be upside down. So those are all shapes of radicals, except that parabola. So how do we graph radical functions? So I thought I put down some steps here to kind of help you through this. Step 1, set what's underneath the radical equal to 0, and then think about how do you get 0 underneath the radical, or just solve there for x. Step 2, then find f of x of the x value you just found, and then graph that ordered pair. Then you want to choose an x value to the left of the x value you just graphed. Determine the f of x value by substituting the x into the function. It might not work because you might end up taking the square root of a negative, and if that's true, then you have to pick a value to the right, which is step 5. If that doesn't work, then you got to go to step 5 and choose a value to the right of the x value graphed in step 3, and determine the f of x value by substituting the x value into the function, and then graph this ordered pair if it's possible. And then step 6, choose another x value in the same direction of the one that works. So if it was to the left and that one worked, then you'd keep choosing ones to the left. If it was to the right, then you keep choosing ones to the right. And then get the y value for that and graph it out. So, and we want a nice smooth graph there. So when you connect them, make a nice smooth graph. All right, so let's walk through this one. So the first thing we're supposed to do here is how do you get 0 underneath the radical? So the only thing underneath the radical there is x, and you're supposed to set that equals 0. So we're going to start our table there off at 0. Go ahead and plug 0 into the function up there. And the square root of 0 there is 0. So I'm going to plot 0, 0. If you choose an x value, now it says to choose, this is step 4, it says choose an x value to the left of 0, so something to the left of 0 would be like -1 or -2. If I tried -1 and then I tried to substitute it in here, the square root of -1, you can't do that. So does not exist there. You can't find the square root of -1. As for a real solution there, so that one's not going to work. So then we have to go back and go to step 5 there, and it says choose an x value to the right of 0. So here's my 0, something to the right there would be like 1, plug 1 in there. Oh yeah, the square root of 1 there is 1. So now I'm going to pick another x value in the same direction, so that's step 6. So maybe something like, I'm looking up there trying to figure out what I can take the square root of nicely up. I'm going to pick 4 because I actually can find the square root of 4. So the square root of 4 there is 2. I could have picked 2, but the square root of 2 doesn't come out to be a very nice answer, although you could do a decimal approximation for your y value as well. Or you could do the square root of 3, which is about 1.73. So if you want to use those values, you can. I usually go to ones that I usually skip some numbers so that I can find the square root of a value that I actually can find the square root of. So now I'm going to plot these other two ordered pairs. So 1, 1, and then 4, 2. And then I'm going to connect them. That's the last step there, step 7 there. Connect them in a nice smooth curve. And it's supposed to be looking like a half of a sideways parabola. All right. We're also supposed to find the domain and range. So if you know domain and range, domain, you have to look left to right. You have to look at the x values. So the x value there on the leftmost side of my graph there is there, and that x value there is 0. Or I can just look in my table there. Your starts there at 0. And then notice the numbers just continue to get bigger and bigger and bigger. So since they're getting larger and larger and larger, and the arrow here goes to the right there forever and ever, that's when it's going to the right forever and ever, that's infinity. And the way you write infinity symbol is you do a sideways 8. So there's my sideways 8. And then infinity is actually not a number that's actually on there, so we're going to put a parentheses by the infinity symbol. All right, let's try the range. Range, you want to look at the y values. From bottom to top on your graph. So what's the bottommost point on your graph? It's right there. And what's the y value there? It's starting there at 0. And then notice it's going up and up forever and ever and ever. So if you notice your values here, it goes 0, 1, 2, and it's going to keep going up, 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 up forever and ever and ever. So that is infinity. Parentheses. Let's look at another one here. Again, take whatever's underneath the square root and set it equals 0. So x plus 2 are both underneath the square root, so we're going to set that equals 0 and solve for x. So that tells me I'm going to plug that in there. Now I'm going to take -2 and plug it into the radical there. So the square root of 0 there is 0. All right. So if you want, typically it's going to go to the right. It's not always, but typically we're going to go to the right there. So I'm going to pick an x value to the right there, so like -1. And so if I plug -1 in there, -1 plus 2 there is 1. And the square root of 1, there's 1. So just like last time, I like to pick values I actually can find the square root of. So I can find the square root of 1, I can find the square root of 4. So when I'm picking my next x value here, I want to end up taking the square root of 4. So x would have to be what in order for me to take the square root of 4? It would have to be 2. Whoops. So we end up getting the square root of 4, which is 2. All right, we can try another one. What's another value if you add 2 there that you can take the square root of? So 3 plus 2, 5, nope. 4 plus 2, 6, nope. 7 plus 2, yeah, 9, 7. So if I put 7 in there, 7 plus 2 is 9, and square root of 9, there's 3. So let's plot those. And then connect them in a nice smooth curve. All right, let's name our domain and range. Remember, domain left to right. So, or just look on your table here. So it starts here at -2 here, and then your numbers just keep getting bigger and bigger. So we're going to do bracket, -2, comma infinity, parentheses. And then look at your y values there. It starts at 0, and the numbers keep getting bigger. So we're going to go 0, comma infinity, parentheses. Well, it's pretty easy to look at the table there. All right, so again, whatever's underneath the radical there, you want to set equals 0 and solve for x. So I can add 3. So that's going to start my table off. Take 3 and plug it into the function up there. So I'm putting 3 in for the x, so 3 minus 3, there's 0. Square root of 0 is 0. Again, I'm going to pick something larger than it. If it doesn't work, then I'll come back and rethink that. So 4. 4 minus 3 there is 1. Square root of 1 is 1. Now again, if I put in 5, 5 minus 2 is 2, and the square root of 2 doesn't come out to be a nice number, so I have to use my calculator to find that. So I'm going to keep going. 6, no, 7, yeah, 7 minus 3 is 4. So now we have 7, 2. What about one more number that we can actually subtract off 3 and find the square root of? That would have to be 12, right? 12 minus 3, there's 9. And the square root of 9, there's 3. So this could be 12, 3. So let's plot them. 4, 1. And then I connect them in a nice smooth curve. All right, domain and range. Domain starts there at 3. Are the numbers getting bigger or smaller? They're getting larger, so that's infinity, parentheses. So I'm looking right here. Starts at 3, getting larger. Starts at 0, gets larger. And so it's getting larger and larger and larger. That's infinity, parentheses. You can also tell because it's going up and to the right. So since it's going to the right, that's infinity. If it's going up, it's infinity for the range. All right, now this one's a little tricky one because the only part that's underneath the square root there is the x. So that's the only part that you set equals 0. So x there is just 0. So plug it into the function. Square root of 0 is 0. Plus 3 is 3. All right, try something larger than 0, maybe like 1. Square root of 1 is 1. Plus 3 is 4. What else can you find the square root of? 4. Square root of 4 is 2. Plus 3 is 5. And then let's try 9 as well. Square root of 9 is 3. Plus 3 is 6. Let's plot them. So there we have our nice graph there. Domain and range. Look at your x values. It starts there at 0 and then gets larger. So that is bracket 0, comma infinity, parentheses. Look at your y values. It starts there at 3 and then it gets larger. So that's 3, comma infinity, parentheses. Example 5 here. Again, this is tricky. There are other things on the outside of the radical. The only part you set equals 0 is the part that's underneath the radical. So it goes x plus 1 equals 0. Solve for x. Set up your table there. Plug in -1. So negative 1 plus 1 is 0. Square root of 0 is 0 times a negative 1 is 0. Minus 3 is a negative 3. All right, pick something larger than negative 1, so maybe like 0. So 0 plus 1 is 1, square root of 1 is 1, times a negative 1, that's what here is on the outside, a negative 1, is negative 1, minus 3 is a negative 4. Pick something larger than 0. So again, I'm thinking in terms of what I can find the square root of. So I'm thinking I need 4 inside there, so if I put 3 in there, 3 plus 1 will give me 4. So 3 plus 1 is 4. Square root of 4 is 2. 2 times that negative 1 there on the outside is a negative 2. And negative 2 minus 3, there's a negative 5. So let's plot them. Notice that one's a little different this time. So let's look at our values this time. They'll start there at negative 1 for your domain, and then they got larger for your x values. Let's look at your range, however. It starts there at negative 3, but they're not getting larger, they're getting smaller. So because of that, they're getting smaller on the very far left over here. Or at the bottom here, if I look at the bottom, well, this isn't the bottom. It's going to keep going down, 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 down. It's going to keep going down forever and ever and ever. It's just a curve going down. Oops. So because it's going down forever and ever, that's negative infinity, and negative infinity always goes on the left. Positive infinity goes on the right, negative infinity goes on the left with a parenthesis. And then because it's, you know, the topmost there is, they're at negative 3, and the bottom there is negative infinity because it keeps going down, down, down. All right, let's try this one as well. Whatever's underneath the square root there, set equals 0. So plug your values in there, so 0. And then 2 times the square root of 0 minus 1. Square root of 0 is 0, times 2 is 0, minus 1 is a negative 1. Plug in 1. The square root of 1 is 1, times 2 is 2, minus 1 is 1. 4. Square root of 4 is 2, times 2 is 4, minus 1 is 3. And let's plot them. So let's look at our domain and range. It starts there at 0 for domain and then just keeps getting larger. For range, starts there at negative 1 and numbers are getting larger. So both of those have an infinity on those. So you can see it's going up and to the right there. So up and to the right is infinity for both of them. All right, again, whatever's underneath the radical there, you have to set equals 0. Solve for x. So if I put 1 in there, one minus 1 is 0, square root of 0 is 0, times a negative 3 is 0, minus 2 is a negative 2. Pick something larger than 1, so maybe like 2. Two minus 1 is 1, square root of 1 is 1, times a negative 3 is negative 3, minus 2 is negative 5. Pick something larger than 2. So when you plug it in there, you can actually take the square root of whatever's in there. So if I put in 5, 5 minus 1 is 4, and I can take the square root of 4. 5 minus 1 is 4, square root of 4 is 2. 2 times the negative 3 is negative 6, minus 2 is a negative 8. So let's plot them. So let's name our domain and range. Look at your x values. They started at 1 and just got larger. So that's easy. 1, infinity, parentheses. What about the y's? Those are not getting larger, they're getting smaller. Negative 2, negative 5, negative 8. So and then look at your graph there. It's going down, 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 down. So the bottom of my graph is down there at negative infinity. And my top of my y value at the very top there is sitting up there at negative 2. So parentheses, negative infinity, comma, negative 2 bracket. All right, and then I wanted us to do some matching here. So let's look at these. So which one of these graphs goes with which one here? So if you think about inside here, how do you get 0? So then if you put negative 1 back in there, the ordered pair there is negative 1, 0. Where the radical there is sitting at. So which one is sitting there at negative 1, 0? This one right there. So number 3 there is letter A. All right, let's try the next one here. Whatever is underneath the radical there, set equals 0 and solve for x. Plug it back in. So we end up getting a negative 1. So we get a negative 1, negative 1. Which one of those, 1 or 2 there, is sitting there at negative 1, negative 1? Oh yeah, this one right here is sitting there at negative 1, negative 1. So number 1 there is B. All right, and let's do the last one here as well. So whatever's underneath the radical, set equals 0. And so plug it in there. So our ordered pair there is 0, negative 1. Which one of those graphs is sitting there at 0, negative 1? Yeah, that one right there starts there at 0, negative 1. So that's letter C. So I can graph a radical function. I can determine the domain and range of a radical function.